This session is about live tiles, and afterwards using background tasks and a maintenance trigger to update your live tile. So most of you have probably already seen these live tiles. It's a great way to make your application feel more alive. So typically you see this in the photo app. A news app is also a good example of where live tile might come in handy. So your news app gets updated with the most, your news app tile gets updated with the most recent news. And as you can see here, there's quite a few types of app tiles. As you see. I'm immediately going to go into the type of tiles that are available. But first, few words on how it actually works. So the tiles you can choose from aren't just random stuff you can create yourself. These are all according to templates, and these templates are built in. So it's quite essential that you choose the best tile for your app, but you have to choose from those templates. Now that can be a combination of text, of different lines of text, of pictures, of only pictures. You actually have optional peak animations, so that means live tiles that show another part of the same live tile in advance, for example. And what's also important to know is that you can update them locally or from the cloud. Now, updating them from the cloud, that's a bit beyond this course, because that would require push notification service to be set up on Azure, etc., etc. So what we're going to do here is show you how a live tile can be created, for which there actually is a built-in helper project, which makes it more easy for you. By default, live tile is actually just a bunch of XML, and these helper classes make it a lot easier to work with this from C#. So you don't actually have to manipulate the XML yourself. So that's the one thing we're going to do, and afterwards we're going to see how we can update this live tile even when your app is not running. So that will be done through a background task. First, let's start by adding a live tile to our application. Now, if you start thinking about live tiles, first thing you have to think about is when would be a good moment to create these live tiles. Well, actually, if you think about it, if you start developing your app, you might think, oh well, whenever I get data that can be put on a live tile, that's a good moment to create a live tile. Well, actually, it's not necessarily the case, because if you think about it, when will your live tile typically be visible to the end user? That is when your application isn't in view anymore. So what would be a good place to create a live tile? That's the suspending event handler. So that's typically a great place to start creating a live tile, depending on the data you have in your application on that moment. Once your app suspends, then would be a good time to create a live tile. So let's do that. I already have an event handler for my suspending event on suspending, and in this one I'm creating a live tile. So let's see how this is done. I'm creating a random tile here from a categories list that's already loaded. And as you might notice, I seem to be using an iTile white image and text 01 interface here, and something called the tile content factory. I'll first talk about this here. There's a bunch of interfaces included, and these interfaces all conform to a specific type of tile. So as I said, there's quite a few types of tiles here, and you can find all of those on MSDN. So this URI, I'll show it later on again, but here you can immediately see all the tiles that are possible, and as I just said, it's actually XML. So this is how you define those tiles. So if you look a bit further, you find rich tiles. These are typical peak tiles. So this is actually one tile, and if you view that as a live tile, you will see it nicely moving from top to bottom. And of course, there's small tiles. That's important to know. The end user can show your app on the start screen in white and in small. You can choose that. If you, for example, let's take the way I have one here, the weather application. I can make that smaller, and it looks like that. I can make that larger, which makes it look like that. This actually means that every time you define a large tile, a white tile, you are obligated to define a square tile as well. It's what you immediately notice once you start programming, because the tile factory will come and complain if you don't. So quite a lot more types of tiles, and you can find all of those on this URI. And okay, on to the tile content factory and this interface here. As you immediately notice, this interface is confirmed to the types of tiles that I've just shown you on MSDN. So it's one interface per type of tile. And all this actually comes from a helper project. And that's the notifications extensions project. This is available through the SDK. So if you go on MSDN and find the Windows 8 SDK samples, it's in there. Just any sample that has to do with a live tile will include this project. And it's actually just a bit of helper content. It's not much more than that. It contains interfaces for each type of tile. It contains a tile content factory, which creates the tile conforming to your interface. And creating that tile, actually, what it actually does is it creates an instance of, in this case, tile white image and text. And afterwards, you fill the object it gives back, and then you state, I now want to update my tile, and that will take that object, convert it to its XML representation, and send it to the necessary tile notificator. So this is actually a bunch of helper classes that make it a lot easier for you to work with live tiles without having to go through working with the XML. As you can see here, this also contains helper classes for toasts, which are the things that show up from the top or the bottom of your screen, and badges, which is what can be shown on lock screens. So quickly show a badge. As you can see here, apparently I just have a Wi-Fi badge and a I am plugged in badge. But there's a few more apps that can be on the lock screen. I think the maximum here is 5. And it's purely user specific, so your user can choose to whether or not to keep a tile on badge on your lock screen. Okay, so that's the helper class. Now let's go back to working with it. So the first thing I need to do, I have already decided I want a tile white image and text 01 template for my tile. So I say tile content factory, create me an instance of this. And then depending on what type of tile you have created, you will be able to set a bunch of properties. So in this case, I have a tile which contains an image and some text. So I should set the text. In this case, I set the text to a random product from my data store, with short title. And it also contains an image, so I can set the URI to the image I get back. Depending on the tile, you can have to set up to 4 or 5 images, extra lines of text. It all depends on what you choose. So it's actually just setting the properties of the instance of the class you just created. And then as I also said, a Y tile must also have a square tile that is linked to it. So what you do then is we want to set the square content property of my tile content, and I'm gonna set that to a tile square image, just an image, for which I use the tile content factory again to create a tile square image. I set the image, I set the tile content.square content to the square content I just created, and then I use the tile update manager to say, well, I want a tile updater for my application, and I want to update it with the tile content I have just created through my helper methods. So this tile update manager is actually included in RT, and tile content, etc. That's from the helper classes. Okay. There's quite a few more options here. You can actually create a tile notification queue just by setting a property to enable the queue. But for now, I'm just going to show you what this will end up in. So let's see, put a breakpoint here. Okay, now I'm going to suspend the app. I'm in create random tile, so let's just run through this. There we go, it should be done. Maybe I should just suspend and terminate. There we go. And now let's see if that actually worked. As you can see here, this is the tile of my Woodgrove banking application, and it's just been updated with, well, you can actually still see that this image is the first one from my list, which is the one I created a random tile from. And normally I can make this a bit smaller, in which you will see we simply have the image, which conforms to the tile I created. The user can also choose to turn the live tile off, by the way, so user is really in control. Okay, so that's how you create a live tile. Now, this will work as long as your application is running and the user suspends it. But imagine you're working on a news application. So a news application, well, that's typically something that you want to have a live tile for, which is up to date as much as possible. So it's a bit of a shame that you have a news application with a live tile, but the only news a user can see on that live tile, well, is the news from the last time you opened the app. So if your user opened the app yesterday, he doesn't see the news from today, even though there is news available. So that's where background tasks come in nicely. Updating a live tile is just one thing you can do with a background task. But it fits nicely with this demo. So as we know, in Windows 8, at least for Windows Store applications, only one application can be run in the foreground. So we have two next to each other in snap mode, but in general there's one that receives most of the resources from the system, and all the other apps are suspended. So there's background tasks to enable us to allow apps to run code in the background, even when the apps themselves are terminated or are not available. So what has to happen is, first of all, we will have to create a background task, which I will immediately show you. You actually do that with a Windows RT runtime component project template. After we've created a task, which is actually just a class that implements iBackground task, we need to ensure that that task is registered for our app using the background task builder. And these tasks can run code periodically, depending on whether or not they're lock screen apps or not, or they can run code in response to system events. So let's check what they can be triggered on. There's quite a few things. There's a time trigger, but that one's only available for lock screen apps. So an application can be placed on the lock screen by the user. And if that is the case, then the application gets more resources from the system and can be is allowed to run background tasks more often. There's also a push notification trigger, also requires lock screen permission. But as you can see, there's quite a lot more we can check for. We can check if a session is connected or not, if an SMS has been received, if the network state changed. It's also an important one. The maintenance trigger is also one that's quite important. Maintenance trigger is something that can be run, even though it's not a lock screen app, that can be asked to run once every 15 minutes. That's the fastest you can run. Even lock screen apps can only run background tasks every 15 minutes. The maintenance trigger allows you to do that even for non-lock screen apps, but maintenance trigger only works when you're plugged in. So, as you might notice from all of this, this is actually all done to ensure that your battery doesn't drain too often, and that your laptop or your tablet isn't occupied by all kinds of tasks running from all kinds of applications while you're in another application. I also have a slide that's coming up on how much time or how much CPU cycles you actually get, and it's not a lot. Of course, there are also a few conditions you can check on. And the interesting thing here is you can check logical things. Is internet available? Is it not available? The thing is, if you have a background task that should only be run once the internet is available, or if the internet is available, and you're not on a lock screen, that means that you can do that once every 2 hours. If internet isn't available, and the condition is that internet should be available, then your task will still be executed from the moment on internet becomes available. So it's not that, oops, there's no internet, so I have to wait for 2 hours again. No, your task will run once the internet comes available if you set that as a condition for the task to run. So that's, I thought it was quite interesting to know when I found that out. So how does this exactly work? Well, actually, you do register it in your application. So it's a background task that does belong to your application. So you register it in your app. You tell it when it has to run, what the triggers are, what the conditions are. But when that trigger is fired, your task will run regardless of the state of your application, and there is no UI involved. So you don't need your user interface of your app to be running. Your app can be terminated even. Your background task will still run. And these are the available resources. So as you can see, a lock screen app gets 2 CPU seconds every 50 minutes. A non-lock screen app gets 1 CPU second every 2 hours. So it's interesting to know it's not that much you get, but it should be sufficient to get through most tasks. 1 CPU second isn't the same as a second. It's a bit more than that. To give an example, it's very, very much possible to have a background task that, for example, contains code that awaits a service call which accesses the Twitter API, gets back a few direct messages or mentions or the latest updates, creates live tiles of that, and that will still be done within the 1 CPU second, as far as I tested. And there's quite a lot more you can do. So it's not a regular second, it's a CPU second. How much regular seconds that is, well, depends on the CPU. So, but of course, don't run too long running tasks in the background. So we'll see how that works. First of all, I will have to create my background task. I'm gonna comment out the creating of the random tile, because now I'm going to create a background task to create my random tile. So I've created a woodgrove.task project, and this is actually a Windows runtime component. So this is not a regular class library, it's a Windows runtime component. That's obligatory, by the way. You can't have tasks in a regular class library. And it does mean there are some extra restrictions. There's quite a few. They can be found on MSDN. But one that's immediately obvious is that your classes will have to be sealed. And they can't just use other unsealed classes from other unsealed interfaces and stuff like that. So it's pretty important, and you can find most of that out on MSDN. So what is a background task? Actually, it's a class implementing iBackground task. That's about it. What is iBackground task? It's an interface containing exactly one method, being the run method. So what we want to do is check if there are tile updates. I actually have a fake tile update service somewhere that's included in this solution. So what we want to do is every time the task runs, I want to call the create tile update method. It is a deferral, by the way, ensures that to run method will not complete its task before this is completed. So I go to the create tile update, and what happens here is I create a new instance of my proxy client, which refers to, in this case, my local host. I call a method on there, get tile updates async. That's just a method on a WCF service that returns me a bunch of tile updates, fake tile updates. And the next thing I do is exactly the same as I did in the creating of the tile. So I again use the tile content factory and those interfaces to create a Y tile. I use it to create a square image for the square tile. And I use the tile update manager to update the tile for this application. The interesting thing here is create tile updater for application is smart enough to know that I have referred or that I am going to link this background task to my application. So it does know from which application it's calling. Maybe also interesting to know is that you can actually provide this with an application ID. I'm not exactly sure of the restrictions on it, but it is possible to create two applications that are linked to each other, and they can update each other's styles. That might be interesting to know if you're working for a company that wants to put out its own bunch of applications that work together. So that's actually all that happens. The one thing that's always interesting to know, a task instance can be cancelled. So the user, by the way, can stop tasks that are running at any time. That would mean your task is gone and you don't know about that. What you typically would do in the cancelled event handler is, imagine that you have a method that calls a service somewhere that can be quite long running and that runs a script on your database or whatever. It would typically be a good idea to create tasks like that or methods like that with cancellation tokens. So you can pass in cancellation token to that service call so that that doesn't keep on consuming resources on your server. Okay. Now in this case, the WCF service I'm using doesn't even support that. Okay. So this is my background task. Now, how do I go about registering that? Let's have a look at my app XAML again. I created a register background task. I call this when my app is launched. First thing I do, you can do two things. In this case, I unregister the task and register it again. Why? Because typically during development, the task tends to change. What you would typically do when your app is up in the store, you would only register it again if it hasn't been registered before, instead of always unregistering and registering again. However, this actually takes a few milliseconds. That's it. Background task registration is built in. And you can use that to check for the tasks that are already registered. In this case, I check whether or not there are tasks with this name. And I unregister them if true. Then I say, well, I'm going to register a new task. I'm going to give it this name. This is something you choose. I'm going to use a background task builder. And set the task entry point to woodgrove.task.update live tile task. It's important that this is exactly the same as the namespace and name of your background task class, else it won't work. So it's very important. As an example, I add a condition that internet must be available, and I state that the task should be triggered by a maintenance trigger every 15 minutes, and the maintenance trigger only runs when your device is plugged in, by the way. And the last thing that's left for me to do is to register the task I just created with the task builder. Now I said last thing, well, that's actually the last thing you have to do as far as coding is concerned. So we now have created a task and we have registered it with our application. We have stated what the conditions are for it to run, and we have created the trigger by which it will run, which will define when it will run. Now there's one more thing we need to do. We need to somehow tell my application that it's capable of having these tasks. And that's through the app manifest file. So every Windows Store application has a package.appxmanifest file. So let's have a look at that one. And in this declarations tab, you can find the background tasks declaration. Once you add one of those, this is another one, you can define when that background task declaration should be run, or what it should, what the triggers are it can be run by. In this case, a system event, maintenance trigger. And you should also say what its entry point is. So this here, that's actually the same as what I've used in my task builder. If you forget this, you will actually get a compile error, by the way. So then again, you do not get a compile error by mistyping in your task builder. So watch out for that. It can cause a bit of a headache.